Atoms are tiny, so tiny you could fit a billion on the head of a pin. Yet inside every atom, there's enough energy to boil a kettle for tea, if only you could get it out. There are two famous ways to release this atomic energy: fission and fusion. Both sound like something from a science fiction film, but they're very real and rather explosive. Fission and fusion are not cousins, but more like opposites. Fission is about splitting big atoms apart, like breaking up a family of bowling balls. Fusion is about squeezing small atoms together until they become one, like two old friends, hugging so tightly they become a new person. Both can make a bang, but they do it in their own style. This essay will take you on a tour of these two atomic acts. We'll visit power stations, peek inside stars, and even stop by a few disasters. Don't worry, safety goggles not required. Ready? Let's start with fission, the workhorse of nuclear power. Let's get to the heart of it. Deep inside a nuclear reactor, something extraordinary is happening every second. How do you convince a giant uranium atom to split in half? It's not as simple as just asking nicely. Well, you need a little helper. This helper is called a neutron. Picture it as a tiny cannonball with no charge. Very sneaky, able to slip right into the heart of the atom without being repelled. When a neutron smashes into a uranium atom, the atom wobbles, shakes, and kaboom, breaks into two smaller atoms, releasing a burst of energy. The process is a bit like playing snooker. Aim the neutron just right, and you'll see the big atom crack apart, sending pieces flying. Unlike with snooker, though, there's no need to shout "pot the black." The uranium does all the work itself once the neutron arrives. And the best part? When one atom splits, it throws out more neutrons, ready to hit other uranium atoms and start the process all over again. This is where things get interesting. Each split releases more neutrons, which can hit more atoms, creating a multiplying effect. It's like popcorn in a hot pan. One pop leads to another, and soon the whole lot is popping, filling the pan with energy and excitement. This is called a chain reaction, and it's what keeps nuclear reactors humming away, generating the power we rely on. But beware. If the chain reaction isn't controlled, you get too many pops at once, and things can quickly spiral out of control. And that, as history has shown us, can lead to disaster, sometimes with devastating consequences. Let's see how that works next, and why control is so important in the world of nuclear fission. Chain reactions are both brilliant and a bit scary. In a power station, scientists control the chain reaction very carefully. They use special rods, called control rods, to catch some of the neutrons, like a referee stopping the game from getting too rough. If you pull out the control rods, things can get out of hand, fast. When the chain reaction goes wild, the reactor heats up too quickly. Even the best kettle in Britain can't handle that much steam. If the pressure isn't released, something has to give. That's when you get a meltdown, which is as bad as it sounds. That's why nuclear power stations have thick walls and lots of safety systems. But even with all these precautions, accidents do happen. Sometimes a chain reaction gets the better of the engineers, with terrible results. Let's look at two famous disasters starting in Ukraine. Chernobyl, a name that still sends a shiver down the spine of anyone who remembers the 1980s. The Chernobyl disaster happened in 1986 in Ukraine, back when it was part of the Soviet Union. It was supposed to be just another safety test. Unfortunately, things didn't go as planned. The engineers turned off too many safety systems, hoping to see how the reactor would cope. Bad idea. The chain reaction sped up, creating more pressure than the reactor could handle. The core got hotter and hotter until, boom, the reactor exploded, sending radioactive dust high into the sky. Radioactive material drifted across Europe. The area around Chernobyl is still too dangerous for people to live in today, all because the chain reaction wasn't controlled. It was a hard lesson in how tricky fission can be when things go wrong. But Chernobyl wasn't the only time nature showed us who's boss. The next disaster came from a different direction, this time from the sea. Fast forward to 2011, and we're in Japan. The Fukushima Daiichi nuclear power plant sat quietly on the coast, just doing its job. Then out of nowhere, a massive earthquake struck. The ground shook, but the reactors held firm. It looked like everything was under control until the tsunami arrived. The tsunami was a wall of water taller than a double-decker bus. It flooded the power station, knocking out the electricity. Suddenly, the pumps that cooled the reactors stopped working. Without cooling, the reactors began to overheat, just like a kettle left to boil dry. Engineers tried everything to stop the meltdown, but nature was just too strong. 3 reactors melted down, releasing radioactive materials into the air and sea. It was another stark reminder fission is powerful, but sometimes it's really hard to control, especially when Mother Nature gets involved. Now let's leave these disasters behind and look to the stars, where fusion works its wonders every day. If fission is about breaking atoms apart into smaller pieces, fusion is about mending them, sort of by joining 2 tiny atoms together to make something new. Fusion happens when 2 small atoms, usually hydrogen, get close enough to stick together, overcoming their natural repulsion. This takes a lot of heat and pressure, like trying to squash 2 rugby balls into one with all your strength. The place where fusion happens best is in the middle of stars, including our sun, where conditions are just right. Inside the sun, it's so hot that atoms whiz around like children on too much sugar, bouncing and colliding constantly. When 2 hydrogen atoms crash into each other hard enough, they merge to make a helium atom, releasing energy in the process. This merging releases a huge amount of energy, enough to light up the whole solar system and power life on Earth. The energy escapes from the sun as light and heat, traveling millions of kilometers to reach us. That's what makes daylight and keeps us warm, allowing plants to grow and life to thrive. Without fusion, we'd be sitting in the dark, shivering and probably quite grumpy, missing the sun's vital warmth. Fusion is the universe's way of keeping the lights on, from our cities to distant galaxies. Scientists dream of bringing this power down to Earth, hoping to create clean, limitless energy for everyone. But as we'll see, it's not as easy as building a sun in your back garden, no matter how clever we get. People everywhere want clean, safe energy to power their lives and protect the planet. Fusion could be the answer we've been searching for. Unlike traditional nuclear fission, it doesn't make nasty radioactive waste that lingers for thousands of years, and there's no risk of a meltdown. Stars don't explode if you spill your tea on them, and neither will fusion reactors. But getting atoms to fuse on Earth is a huge scientific and engineering challenge. To make fusion happen, you need to heat hydrogen to millions of degrees, hotter even than the sun's surface itself. Then you have to hold it together long enough for the atoms to merge and release energy. This is like trying to hold a jelly with knitting needles, delicate, tricky, and easy to lose control. Scientists are building giant machines called tokamaks and using powerful lasers that zap hydrogen until it fuses. It's not easy, and it's definitely not cheap, requiring years of research and investment. But if we succeed, fusion could give us endless, reliable energy for generations to come. No pollution, no long-lasting waste, and no risk of catastrophic meltdowns. It's the dream of clean, star-powered electricity for everyone, everywhere on Earth. Fusion is still a work in progress with many hurdles left to overcome. But every year we get a little closer to making it happen, step by step. The future might be brighter than ever, thanks to a bit of atomic magic and human ingenuity. So, there you have it. The explosive truth about fission and fusion. Fission powers our reactors today, but it comes with risks. Chain reactions need careful control, as Chernobyl and Fukushima have shown us the hard way. Fusion, on the other hand, lights up the stars and could one day power our world safely if we can learn to handle the heat. Both fission and fusion are reminders of how much power hides in the heart of every atom. It's like having a dragon in your cellar. Amazing, but handle with care. Scientists will keep working to make atomic power safer and cleaner for all of us. Who knows? Maybe one day we'll all be sipping tea under the warm glow of fusion energy. Until then, let's keep our eyes on the stars and our fingers crossed.